Welcome back. In this video, we will look into the consistent hashing. So consistent hashing comes into a picture whenever we have a need to distribute a workload over a distributed system. This workload could either be a data or a request. If it is data in computer science, we call it like a data partitioning problem. Okay. So let's look at the problem statement what we have. So let's say we have a lot of data which can't be fitted into the single host. Okay. So now we have a need to distribute these data over a multiple set of server S1, S2 and say like Sn. So we have to figure out what this algorithm could be so that this distribution could be more as much as efficient as it can. Okay. So our data has like a primary key and few non-PKs. Okay. Now moving to the first algorithm which we have proposed is basically like a function which takes the hash of the primary key and then modulates with n. N is like a number of server. In this case, for an example, it's n equal to 3. Okay. So let's look at, we have some k1, k2, k3, k4 and let's say like its hash is 8, 2, 1, 6. Then fk will be like modulo of n. So 8 modulo 3 is 2, 2 modulo 3 is 2, 1 modulo 1 is 3 is 1, 6 modulo 3 is 0. Okay. So this means like S2 will hold like k1 key and k2 key, S1 will hold like k3 and S0 will hold like k4. Okay. Now do you see a problem? Now suppose a new node gets added. Because we are building a scalable system, if you think like a scalable is can grow and shrink as always. So if a new node is added, let's say S4, and basically now change to 4. So n is no longer 3, it's 4. So this whole computation we need to do it again. So f of k will then become, this will be 0, this will be 2, this will be 1, this will be 2. Now the whole distribution, if you see, now S2, basically S4 will hold nothing. This will be S3 actually. So S3 will hold nothing. Sorry, S2 will hold K2 and K4 and S1 will hold K3. So if you see, now there's a wide range of distribution happening here, right? Now S0 has changed to K1, S1 has changed to K3, S2 has changed to K2, K4. So you see there is a like lot of data movement. So there is a problem, right? There's lot of data movement. Okay. Another problem you can see is like we are creating a hotspot, like because there is a non-uniform distribution, it is leading to a hotspot. Like some node is having more data, some has having less data, right? So let's move to the next algorithm which can help us to fix this. Okay. As we saw, previous simple hashing algorithm has some downside. So let's look at the new algorithm which can help us to fix this issue. So the algorithm begins in this manner. So we take a key, the primary key, which was we were doing the earlier as well, and take a hash. Okay. And now we assume that the hash will range in between 1 to 100. If we are doing some MD5 hash, which is like a 32-bit, then the hash will be like 1 to 2 to the power 32 minus 1. Okay. Now coming to what is the next part. So in this we arrange the server in a ring manner. So basically if the hash of a key will come into the range of like 1 to 25, 1 to 25 it will be assigned to this node. Similarly 26 to 50 it will assign to this node. 51 to 75 if the key comes in the range this, it will assign to this node, and 76 to 100 it will go to this node. Okay. So now let's see how this solves the problem with the simple hashing algorithm, which was the data movement first. Okay, let's say a new node is added. Okay, let's say any node is added here. So if you think wisely, which data will be moved? So there is no impact here because no node is added here, no node is added here, no node is added here. The node is added here. So basically now the data movement should happen here. So all the keys which were falling in this range earlier was getting mapped to this node. But now since a new node has come, these keys should be mapped to this, right? So all the keys which were mapped, which were in this range, which was earlier mapped to this, will have to come from this server, let's say S0, to a new server, let's say S4, right? So only data movement is like from S0 to S4. No other nodes are impacted. Now let's say how this solves the hotspot problem. Okay, the second problem which we had. Now let's say if a node is removed, let's say this node is removed. Okay, so what will happen? So all the data which was in this range, like which was stored in this node, has to be moved to this node, right? So this node is now holding entire range from 26 to 75, right? So if you see, now this is overpopulated. So it kind of becomes like an hotspot. So basically this algorithm does not solve the hotspot problem, but it reduces the data movement, as we have seen clearly here. Only the data movement required was from S0 to S4. Did you notice one thing in the last algorithm? What happens if we increase the number of node? If we increase the number of node, we basically brings more uniformity in the key distribution. Let's say we have less node, all these keys will belong to let's say S2 in this case. But what if I add a new node, a lot of node, then basically these small ranges will go to a single server, right? And if these happens, basically there will be like a less data movement and less chances of creation of an hotspot. Okay, so the next algorithm tries to do the same thing to solve the problem of the hotspot. It tries to introduce a lot of virtual server in the cluster. So it will basically mark it like VS0. So these are virtual node, which does not exist physically, but we have created it. So this is VS2, this is like VS1, VS3. So now if you see, the range has become smaller. So if the key range is in this, the node will be VS3. So S3 will hold all the keys whose hash lies in this range. Similarly, if the hash lies in this range, like between VS3 and VS2, it will go to like S2, and same thing happens, right? Let's say S1, S2, VS2. So it will basically go to all the keys will basically map to S2. So all the keys will be mapped to S2. So if you see, like we increase the number of node, which we do through a virtual node, the key range reduces, key becomes more uniform, causing less data movement, which we already saw in the previous algorithm, but also the less chances of creation of an hotspot because it is distributed randomly, uniformly. So this is the algorithm which basically solves both the problem of data movement and hotspot. Cool. So now what happens if a node leaves? Let's say we have the algorithm, but what happens if a node leaves? So now if a node leaves, all its data will be gone because the physical memory has gone, right? So in order to cope up this, what concept called data replication. So what will happen is, like whatever data is stored in this, we will replicate it to the next n neighbor or next k neighbor. So that k neighbor is basically the replication factor. So now if a node goes down, we will basically go to all its k neighbor, like k next neighbor in the counterclockwise manner, and figure out what all data was stored there. Now, where is this consistent hashing will be used in your system design interview? So wherever there is a data storage partitioning problem, request partitioning problem, or request distribution problem in a scale up manner, like data node can go up and go down, we will be using consistent hashing. Okay, so I think this sums up the entire video. Okay, bye.